All collection classes implement the collection interface, or a subinterface of the collection interface. Its definition begins this way. You can see that it uses a generic to specify the kind of objects it can hold. Oh, by the way, the objects held in a collection are called elements. You can also see that this interface is an extension of the iterable interface. I'll be talking about that here in a minute. Several methods are defined in this interface. In fact, a group of fundamental methods used in all collections can be found in the collections interface. Now, not all the methods are always implemented because for some collections, not all the methods make sense. But by using the interface and its standard method names, it's possible to pass elements from one type of collection to another. In fact, every collection class has two constructors. The default constructor, which has no arguments and simply builds an empty collection object, and another constructor that will accept any collection object as its argument. It builds a new collection holding all the elements found in the original collection. This makes it dead simple to transfer all of the elements from one type of organization to another. Anyway, the methods. These first two methods tell you about the contents. The size method returns the number of elements in the collection, and the isEmpty method returns true only if the collection is empty. The contains method returns true only if the specified element is in the collection. The add method inserts a single element into the collection only if it is not already there. The returned value is true only if the element was added. The bottom line, when this method returns, the element is in the collection. This method removes the specified element from the collection. The two array methods extract a list of elements and returns it to you as an array. I have some examples of doing this coming up. The iterator method encapsulates the elements of the collection in an iterator object, which can be used in a loop to extract the elements one at a time. There has been an addition to the Java language to facilitate doing this. The collection itself is an iterable object, which only means it can construct and return an iterator. Finally, there is a group of methods that operate on the entire collection. Contains all compares the contents of the two collections. Add all copies the contents of one collection to another. Retain all results in the collection containing only the elements found in both collections. Remove all removes the collection elements that are in the specified collection. Clear removes all elements. Almost all collections will have more methods than this, but this is enough to make certain that collections are compatible. Actually, some of these are optional in that they don't do anything for some collections. This interface has 10 sub-interfaces, and most collections implement one of those. As you saw earlier, the collections interface itself is a sub-interface of the iterable interface. All the iterable interface does is guarantee the presence of one method, the method that will return an iterator object. The interface defining an iterator object looks like this. It's set up so it can read sequentially through the collection one time. You have to call hasNext to determine whether there is another element to be read, and the next method then will return it to you. The remove element will remove an element from the underlying collection. In fact, it's the only safe way to modify a collection and continue to use the iterator. Using an iterator is straightforward enough, and it gives you control over your iteration. But some new syntax has been added to the Java language just for this special purpose. This special form of a for loop is for iterator objects only. The reference to an object named O is declared as a new variable. The body of the loop is executed once for each object in the collection, with the reference O containing the address of the element from the list. It's just as though you had called the methods to get objects, except that you don't have access to the remove method. Also, this structure prevents you from looping through the contents of more than one collection at a time. A more general way to do it would be like this. This loop does the same thing using more traditional forms of Java. This gives you more control over what's going on. It also is a bit more clear and makes it possible to call the remove method. In the next lesson, a concrete example of using an existing general purpose collection.